Hello. So this is a project that was started by Ornell a couple of years ago, and got sidetracked by the IP version 6 work. But the good news is it's actually, now that the IP6 work is starting to wrap up, we're refocusing our efforts on this. Also, the other person who was working on this project at Ornell, Adam Disney, moved on to other employment, so he left the project. So the reason why we want to do this solution at Ornell, what's important is the current state of resiliency. So one of the big problems with Lustre is that now we have these very large systems and they fail even with these high-end software. So even the best hardware now is starting to look like low-end hardware at these incredible scales. And originally Lustre was designed, it originally started out at DOE facilities, and we had the highest end hardware out there. So it was extremely resilient hardware, and failures were pretty rare, especially in the early days. The scales weren't as they are today. So when Lustre was built, it was built with one thing in mind: run as fast as possible, but it didn't care about failures. So failures didn't matter. Like, for example, at our sites, we just reboot nodes if they went down, and that was how we handled things. So how do we handle such problems? Well, the most common way is, and you probably do this all the time when you're doing Lustre development, is do you turn it on and off? So that's a common, why I'm doing testing and things bug, I just reboot the node and try again. So the other solution is failover pairs. So usually everybody does failover pairs, but Lustre doesn't have internal mechanisms really to handle this, so you have to use things like Pacemaker to kind of automate this process. And then, of course, as time went on, people wanted some kind of replication. So we had mirroring developed. So we have file-level replication, and there's different phases of this file-level replication. Only phase 1, to my knowledge, has been completed. So there's phase 2 and phase 3 and phase 4. So these are the things that we're trying to address this. So in file level replication, it's just mirror. It's your basic exact duplication of data. And that's where that is today. So we have like a basic, mirror RAID format. You can have up to 16 mirrors. The way it works, though, is it's not an automatic system. So here's a question. Has anyone ever used the mirroring functionality here? One person. Well, that's more than 0. So that's actually not, that's not horrible. So actually, there are the severe limitations. It usually requires a manual resync, so often the data becomes stale. And there's all the mirrors are equally stale. So there's no primary, phase 2, there was a discussion of making one of the mirrors at least try to keep in sync. And of course, the other problem with this is that the weakness is it duplicates, it's a doubling of the data or more. You can go up to 16x of your data size. So you can see that there are limitations to this design. So we were looking at on our systems, we want to be able to not be able to have to manage this kind of stuff and actually be able to keep running while a node goes down. So one of the projects that WebCloud decided was in phase 4. So this was way down the roadmap actually for erasure coding. It's actually, the work was started actually much earlier than that. We haven't even started phase 2, or maybe phase 2 is in some early, nope, phase 2 is not. So it hasn't even been started. So we're actually jumping the gun because that's how important this work is. And this work was started a bit earlier. Like I said, it was started 2 years ago. It's a unique type of erasure coding. It's not your typical RAID 5 or RAID 6. We have M-to-N coding, so you can have M amount of data components and N amount of parity coding. So it's an interesting design. It's actually much more flexible than your basic RAID 5. The original patches were written by Bobby Jam, and those are the LRU tickets of this work. All this work, there's been, the prototype is, like I said, Ornell picked it up. We started working on it and updating it, working out various bugs. So it's actually in good shape. I've been keeping it up to date. We do test it to make sure we don't break we've been looking at testing the regressions. We actually have to test, write like a sanity for erasure coding, so that's the next step. So what is done in those patches? So one is layout support. So the LOD layer and the LOV layer have abstractions for the way the components are handled. So erasure coding is a part of a data component, but it's a unique type of data component. We can send write intents to the MDT. The user land tools have been updated to handle the EC components, so you can actually create these erasure components and do the, so as you can see, I gave you an example of a set stripe with a data component on a file. And in this case, it's like there's 4 data components in the stripe, and then the parity, you create 2 erasure coding parity components. Of course, we can update the parity value. So actually there is, just like regular mirroring, currently the code is written such that you can update it manually, that parity value, and then store it on the LD backend. And so we have the ability to sync and create those values. We also have code to, if you use the mirror resync, just like regular mirror, you can actually restore your damaged file. So it is possible to do this. And as I was saying before, we're doing basic validation of this code all the time, and as we keep it up in sync. And we need to place that kind of testing in a sanity ec.sh file. So this is kind of like what it looks like. This is how your layouts are done. So you have your regular OST and your data components. So the nice thing is that we've fixed up the code so that the parity checking values don't have to be at the end of your component, your layout. So it can be actually anywhere among that data. So it's a bit more flexible than that. So in this case, we're creating a component in the front, 0 to 3 on the OST1, and then we created another component. And then at the end, we do the parity checking, and we're doing it against OST1 through OST4. And as you can see, the way the structure's done, right now we're doing data, the amount of, with the data there, the yellow blocks, to the amount of parity coding values created. I think that's not flexible, so this is something we're going to discuss. So one of the things that we were looking at, I was thinking about doing, is changing, not that it's the number of data components, but actually like a ratio. So that way, if we do like migration and it changes, it tries to keep that ratio. It would be a lot more flexible to do that. The other thing is the way the current implementation is done is even though it does data count of 4 like there, it doesn't, you can actually theoretically not have to do the 4. And also we can't pick which data component to actually do the parity check on. So there's some ideas. I have an idea of using like a foreign component to store the data for the parity checking, to tell you what OSTs are being, what data components are actually being parity checked, and that way you can control it. So those are some of the ideas on that. So that actually makes a bit more sense. But this was the initial design. So what are some of the gaps? So after I looked at that, what we currently have versus what we have, so there are some large gaps in this implementation, which I was discussing with Andreas. So the good news is that the current implementation, what we have, will cover about 80% of the cases. So basically, we can make it such that your jobs will keep running if a backend goes down, and it can use the parity check to reconstruct your data and do it in the local page cache. And your data, you can update that in the local page cache, but then when the server comes back, it can synchronize that data. So, but of course, that's not automatic. So we have all the same issues as regular mirror component. So we have no automatic updating of the parity. We have no automatic data placement. Like I was saying, we don't really have the ability to control, like if you have odd number of components that don't fit the model. So those things have to be worked out. Also, there's not really range checking. So like you have, say, 20 data components, and you try to make erasure components of 50. That doesn't make sense. So we need to do some sanity checking for that. There's no real checking of the placement. So right now, you can't control like which OSTs are being done, and you can't select them, so it's kind of a blind shoot, and you just hope that you do everything correctly. Those are issues to be done. The other thing, which is a big issue for the first start of this project, is how does this interact with now? So when this code was originally written, we didn't have FS crypt. We didn't have compression in the plan. There's a lot of extra details. So how do you interact it with these, in which order? So right now you're going to encrypt it, and you're going to compress it and send it to the server and do the parity checking on that data. But then if you're in recovery, how do you do that? Because you have to like recompress and uncompress it and unencrypt it to actually recreate the data every time. So that's a very expensive process. So do we do the parity checking on the original data? That way we don't have to uncompress it and unencrypt it every time. The other question is pools. How does it interact with pools? So I was thinking about that. So those are some questions that I thought about. Like, if it's part of a pool, do you allow components to do parity checking on components that are outside of the pool? Is that a valid state? In recovery itself, this was one of the things brought up. I believe it was Alexi's kind of asking, what do you do with recovery? So normally we have transaction IDs, and we reconstruct the message. If pieces are missing, of course, that makes sense to use the erasure component to do this. But is erasure component actually more efficient? Could we drop like the transactions on the file and reuse the erasure component just to rebuild the file there and just sync up the data, the final data, to the server? So there could be some optimizations there. But then the question is, when do you use the erasure component data, or do you toss it away at various times? So the other thing, and of course, like I was pointing out, there's file migration. So if you're moving from one tier to the other, how do you deal with those erasure components? Do you just drop them when we migrate with HSM? Do we recreate new parity checking because it's going to be different layout? Do we store it? Is it even important to the user? Do we want users to be able to get the parity checking values? So those are things. I don't know if admins would be interested in that kind of software. Where do you want that the parity, or is it something just internal that anybody has? The other limitations, as well as we were discussing, was data size of the erasure components itself. So now that when your users are going to be creating files and they have erasure data, parity data, that's going to consume a lot more space. This is an issue also with mirroring, and I don't think anyone has thought about it, but what about quota spaces? So we have hard spaces and soft limits. Do we include it in the soft limit limit for the file? Should we add that in the calculation? Because it is consuming space on your servers. But then to the user, that's invisible, and they don't know that that space is being consumed. So, and then of course, when we did the implementation, we have no hardware acceleration of the Reed-Solomon codes. So we haven't been able, that is last on the list, though it's a very crucial thing because this is an expensive process. So those are all the gaps that they're going to be worked on. So the initial plan was that this was not, we weren't going to do the initial what we have now, but I would really love to challenge like these things in the 2.17 release because it's pretty well developed ahead. Thanks to the long period of 2.16, we were able to fill in a lot of the gaps. So I just, yeah, this is a brief one because a lot of the work is done and there's things to do. So I just wanted to let people know that this work is going to be done, and this has been a very big thing that a lot of people have been wishing for. So it's going to become a reality. We already have a patch set that's, I have local, that's in pretty good shape, and it's pretty far along in the development. So we'll be doing reviews, and when 2.17 opens, I'll be pushing it. In fact, the patches were pushed, though those are kind of outdated now in Garrett. You can actually see all those patches. There's a lot of gaps, though, looking at the initial implementation that I would love to see filled in for 2.17. And of course, as I'm presenting this, of course, administrators here, if anything I've missed that would be of concern to you, please let me know, because I am not all-seeing for what you do with your users, and I have no idea what your users will do to your systems with this work. So it would be great if you tell me what, to make sure that I cover all the gaps. And of course, testers are always welcomed, and please please test this out. I assume that there are some sites like Stanford who's quite bold in testing development branches. Thank you for testing stuff and reporting bugs to me. This would be very, very good to have some bleeding edge sites test this out. All right. And I want to acknowledge that this was done under the Department of Energy, who has a very strong interest in this, and they've contributed this work. And I also want to make a small mention. I know no one has talked about it, so I want to say that I would like to consider this work dedicated to Olaf Weber. He passed away. He was a Lustre developer this year. And I've worked with him on the LNet, so he'll be missed. Thank you very much. And if you have any questions.
When you're asking for testers, are you asking for production sites, or is it people with available hardware?
I'll take anything. I mean, I'm as long as you can test it and see if you can break it, I'm fine with that. Because we don't test it in production, this kind of stuff. We have our own test beds, and we exercise it through there.
Maybe available hardware first.
Yes, make the hard, yes.
don't have a question, but more of a comment about the phases. It was never intended for them to be a sequential 1, 2, 3, 4. In fact, when we were at the SC17 Lustre, we did a show of hands voting for which we would do next, and overwhelmingly erasure coding got nearly every hand. So that's why we had started work on that, but not the other phases.
Thanks for the presentation. So who does the work of verifying the checksum or repairing the data? Is it the server that does it, or is it the client?
It's actually the client does that. It actually reconstructs the file. So the reason we want to do that, of course, is because if the server's down, the data is marked staled on the server, but the new parity coding is kept up to date on, it's used to reconstruct the file. And then if you write to the file, it's going to do a new parity value locally on the client. But then when the server comes back, it's going to resynchronize it and not mark it stale.
Okay, yeah. And then another thing I started thinking about was overstriping, probably EC data.
I forgot to mention it. That is yet another problem, and that's another reason why I talked about instead of using the number of EC data components versus to do a ratio. Because if you have a ratio, as you mark it, it can generate a parity value once you hit that threshold. So that's another excellent comment. Thank you. I forgot to mention that.
Yeah, so I mean, one of the important things that with the design is that you can have parity that's not exactly equal to the number of stripes in the file. So as long as you're, let's say you have a 32 stripe file, you can have 8+2 erasure coding in there so that every 8 stripes get 2 parity stripes. And so if you're doing erasure coding, as long as your overstriping, as long as your parities don't overlap with, that set of stripes, you can still have, let's say, whatever, 4 times, stripes on one server, as long as each of those stripes has parity that are on different OSTs, right? And even if your file was striped over every OST, say you have 40 OSTs, you have 40 stripes on a file, as long as the sub-erasure coding is on different OSTs and OSSs hopefully as well, then you can still withstand like OST failure, right? And the problem with if you have, 1,000 stripe file, you don't want to have to read 1,000 stripes of data and have like 100 parities to recompute. It's just totally impractical, right? So you really want to have substriping, so it's in the 8 to 16 or 24 kind of range to get good efficient computation, because you will have to read all of the data for that many stripes and then the parities in order to rebuild, right? So you don't want to do that for, reading a gigabyte of data to rebuild like 1 megabyte of missing stripe.
Yeah. The other thing we considered too was doing parity checks of the parity check components as well. So that way, if some of the data, this was discussed internally, so that way we could, if that data somehow got corrupt or lost, we could reconstruct the parity codes and values themselves. Just in case you had like a triple disk failure, and they say that never happens, but it does happen in production.
Okay. James, is the intent or your intent at Oak Ridge to use erasure coding on direct disks or NVMe device and not use, RAID 6 on OSTs anymore, and basically like Ceph, or MinIO, you attach direct drives as OSTs, and erasure coding would protect us from failures.
Right.
Then that means we'll have very frequent OSTs failures. How are you going to manage that?
So you have frequent OST failures?
Well, if you don't have like RAID 6 on OSTs anymore, because we will rely fully on erasure coding.
Okay.
Otherwise, is your intent to use erasure coding on top of reliable OSTs? So.
Yes.
The second one.
The second one.
Okay.
Yeah.
Okay.
You don't want an OST to have to do rebuilds just from
That makes sense. Okay.
Yeah, you don't want to have to rebuild your whole OST just because one drive dies and go through recovery and things like that. So it's meant to be a multi-tier.
It's an additional layer of protection.
Yeah, it's an additional, yeah.
Thanks.
Quick comment on, the compatibility between erasure coding and encrypted files. So if I understand correctly, the reconstruction will happen on client side, and the erasure, the parities are computed on server side. So on server side, the servers only see encrypted data. It's just like arbitrary data for them. They're not aware that it's encrypted. So it means that when you reconstruct from these parities, it would have to be done without the encryption key, so that the client can just does the reverse computation, and once it reveals the encrypted version of the file, then I guess it's fine and it can be re-decrypted.
Okay.
So thank you. Any other question?